Alright, we're going to look at two new parent functions today, the square root and the cube root functions. So first we're going to look at the square root function. H of x equals the square root of x. We're going to pick x's that are perfect square roots. So the square root of 0 is 0, the square root of 1 is 1, the square root of 4 is 2. Now our pattern continues. If we have 9, we have the square root of 9 is 3. If we have 16, we have the square root of 16 is 4, and so forth and so on. So it's just how we're going to graph as many points that will fit on a graph. Alright, so our 0, 0, where we start, this acts like our HK. It's not called a vertex here. And then we're going to go right 1, up 1, right 4, 1, 2, 3, 4, up 2. And if it fits, 9, 3. And that's the last point that fit. So a square root graph, because you can't have negatives underneath the square root, they're imaginary, we only have going one direction. So the domain here is going to be, it's going to start at 0, and that's a bracket, and it continues only to the right, so that's positive infinity, or x greater than or equal to 0. Our range here, again, this one starts at y and it's going up, so it's going to be bracket to infinity, or y is greater than or equal to 0. As x approaches positive infinity, f of x is getting larger, so it's approaching positive infinity. Now here, x approaches negative infinity. Because we have a restriction on our domain, we can't get to negative infinity. So that means this does not exist. Alright, notice the general form of a vertex form of a square root function is a square root of x minus h plus k. And a, h, and k are going to work the same here as they've done in all of our other functions. Alright, the cube root function, y equals the cube root of x, we're going to pick values that are perfect cube roots. Now you can take the cube root of a negative number, so that's why we start at negative 8. So the cube root of negative 8 is negative 2, cube root of negative 1 is negative 1, cube root of 0 is 0, the cube root of 1 is 1, and the cube root of 8 is 2. And like I said, we can continue with our pattern like 27, the cube root of 27 is 3. Alright, so HK is going to be our 0, 0. And so we're going to go from our 0, 0, we're going to go left 8, down 2, left 1, down 1, right 1, up 1, and then 8, 2. And so our cube root function is going to look like this. You can see that it's continuously increasing. It's an increasing function the entire width. Our domain and range, there's no restriction, so they're both all reals. And as x approaches positive infinity, y is getting larger, so that's also positive infinity. And this one does have an end behavior on the left. As x approaches negative infinity, y is going down, so it's also approaching negative infinity. Here again, look at our general form of our equation. Okay, so let's move these things around. Let's do some transformational graphing. Alright, notice this is a square root. So get your pattern set up. I'm going to try 0, 1, 4, and maybe 9 if it fits. So I've got 0, 1, 2, and 3. Alright, here my a is negative 1. So I'm multiplying all these values by negative 1. So negative 1, negative 2, negative 3. And my HK here is 4, 3. So that's where I'm going to start my counting. So 4, 3. Alright, I'm going to go right 1, down 1, right 4, down 2. And that's all the points I can fit. So my graph looks like this. Alright, my domain here starts at 4 and gets bigger, so it's x greater than or equal to 4. And my range, or we can write it in interval notation. And then my range is going down this time, so it's going to be y less than or equal to 3, or negative infinity to 3 bracket. The entire thing is decreasing, so we start at 4 and go to infinity. I'm sorry, that's decreasing, not increasing. So it starts at 4 when we're open, and then goes to infinity, and we have no increasing interval, none. All right, in behavior, we don't have any to the left because we can't get to negative infinity, but as x gets bigger and bigger, y is going smaller, so it's negative infinity. All right, still a square root graph. 0, 1, 4, 0, 1, 2. It's all about recognizing that pattern when we see that square root. This time a is 2, so we're going to double. So this becomes 2 and 4. All right, h is negative 1 and k is 0. So that's where we're going to start counting at negative 1, 0. All right, so we'll go right 1 up 2, right 4 up 4. And I might be able to fit 3, 9, 3, which will become 6. All right, so here is my function. Domain x greater than or equal to negative 1, and my range y greater than or equal to 0. This one's entirely increasing, so we start at negative 1 and go to infinity, and there's no decreasing interval. As x gets smaller, okay, here again we have no. As x gets bigger, y is getting bigger, so that's positive infinity. All right, notice we've changed. Now we've got a cube root. So I'm going to use that pattern. Here again, it's all about seeing what function I have and then using the parent points. All right, this time a is a half. This becomes negative 1, negative a half, 1/2, and 1. And my hk is negative 3, negative 2. So that's where I'm going to start counting. That acts like my 0, 0. It's going to be the middle of my graph. So negative 3, negative 2. All right, from that I'm going to go left 8, down 1. Left 1, down a half. Right 1, up a half, and right 8, up 1. All right, so here is my function. All right, domain and range are all reals. This one's entirely increasing on the interval, and there's none for decreasing. As x gets smaller, y is getting smaller. And x is getting bigger, y is getting bigger. All right, look at this one. Still a cube root. So get our parent points. Here a is negative 1, so we're going to change the signs. And here my h is 0 and my k is 4. So that's where I'm going to start counting. That acts like my 0, 0. So 0, 4. So I'm going to go left 8, up 2. Left 1, up 1. Right 1, down 1. And then right 8, down 2. So here's my function. Alright, domain and range are all reals. This time we're entirely decreasing, so there's none for the increasing, and decreasing on the entire interval from positive to negative infinity. And as x approaches negative infinity, my y is actually getting bigger. And as y approaches positive infinity, my y is getting smaller.